In this lesson, we were going to be learning about prime factorization and finding the greatest common factor. Okay, so this should be familiar for finding the greatest common factor of numbers, but now we're going to do it with monomials. Okay, so just to review, a prime number is a number that can be divided only by the number 1 and itself. Okay, so for example, like the number 3, because you can only do 3 times 1 to get 3. Okay, the number 5 is prime because you can only do 5 times 1. And let's say the number 7 is also prime because you can only do 7 times 1. Okay, a composite number is a number greater than 1 that is not prime. Okay, so this can be numbers like the number 4. I can do 2 times 2 or 4 times 1 to get 4. Okay, the number 12 is composite because I can do 3 times 4, 6 times 2, and 12 times 1 in order to get it. Okay? So let's look at the number 37. What are the factors of 37? I can do 1 times 37, and that's actually it. So 37 is going to be prime. And 24. 24 we can do 1 times 24, 2 times 12, 3 times 8, 4 times 6, okay, and that's it. So because we have more than just the 1 by itself in the number 1, this is composite. Okay, so just to review a little bit for prime factorization, that's taking out the prime numbers. So we can list the first 5 prime numbers, 2, 3, 5, 7, and 11. Okay, we want to try and take out these prime numbers from 84. So 2 times 84 is 42. Okay, so I circle the prime. And then from 42, I can do 6 times 7. Okay, 7 is prime. Circle the 7. And then from 6, I can do 2 times 3. Okay, and these are all prime. So everything that's prime is the prime factorization. Okay, because I have 2 number 2's here, I'm going to change it to 2 squared times 3 times 7. This is going to be your prime factorization. Okay, so if we want to do prime factorization including negative numbers, the first thing that we would need to do is negative 1 times 210. Okay, we want to take out that negative. Then everything else is the same. Okay, so to get 210, I can do 10 times 21. Okay, neither of these are prime yet, so I need to continue. 5 times 2 is 10. These are both prime. And 3 times 7 is 21, and these are both prime. Okay, so then the prime factorization here is going to be negative 1 times 5 times 2 times 3 times 7. Okay, so doing prime factorization including variables is going to look like this. Okay, so here we have the monomial of 45a squared b to the third. Okay, so in order to factor this, I can take the factor tree of 45. So 5 times 9 is 45. 5 is prime. And for 9, I have 3 times 3. If I want to factor a squared, a times a gives me a squared. And factoring b to the third, b times b times b gives me b to the third. Okay, so I have 3. Okay, so if I want to go ahead and write the prime factorization here, I have 3 times 3 times 5 times a times a times b times b times b. Okay, so this would be the prime factorization. Okay, so pause the video for a moment and try this one on your own. Okay, so to rewrite this in your notes, looks like this. Okay, so prime factorization of 12. 2 times 6 and 2 times 3. Okay, factoring here I have 2 times 2 times 3. If I want to factor a to the fourth, it's a times a times a times a. So I'm going to add that in. And then factoring b to the third is b times b times b. Okay, so our answer is here. Okay, I know it looks really long. Okay, so now that we've gone over prime factorization and factoring, we want to find the greatest common factor, okay? So to review, let's just do it with the number 42 and the number 60, okay? So 42, I can do 6 times 7 and 2 times 3. Okay, so for 60, I can do 6 times 10 and 2 times 3 here. And for 10, 5 times 2. Okay, so now I have all of my prime numbers circled, okay? So this is a little trick we can use where we have the number 42 here and the number 60 here, okay? So anything that is the same is going to go in the center, and everything that's left over is going to go on the outside. Okay, so I see that I have a 3 here and a 3 here, so I'm going to put a 3 in the center because they both have one. Okay, so I'm only using the numbers that are circled, that are the prime numbers. Here I have a 2 and a 2 here, so they both have a 2, so it goes in the center. Okay, and that's really it for here that they have in common. Okay, so in order to get the greatest common factor, the GCF, I'm going to multiply all of the numbers together that are in the center. So this would be 6. 2 times 3 is 6. Okay. Another way that you might have learned before is listing them all out and finding the factor that is the greatest that they have in common. Okay, so doing greatest common factor, including monomials now. Okay, so here it's the same idea. I'm going to first factor the whole number. So 4 times 10, 2 times 2. Okay, circle the prime, and 5 times 2. For 48, I can do 2 times 24, 2 times 12, 2 times 6, and 2 times 3. Okay, then I also see that I have here a squared, so I have 2 a's, so I'm going to just write a, and then I have 1b. Okay, here I have 1a, and b to the 4th, so I have 4 b's. 1, 2, 3, 4. Okay, so now using the Venn diagram, I'm going to put together the ones that are in common. Okay, actually let me erase this a little bit. I'm going to make the center a little bit bigger. Okay, so here is 40a squared b, and here is 48ab to the 4th. Okay, so let's see what's in common. I have a 2 here and a 2 here. Another 2 and another 2. Here I have one more 2, one more 2. Okay, that looks like it for the numbers that are in common. I have an A and an A. And then I can match up one B here with one of the B's over here. And those are the only ones that are in common, okay? So I'm going to multiply everything that's in the center. So 2 times 2 times 2 is 8, AB. Okay, so this is the greatest common factor, 8AB. So the whole point we're doing this is because the unit's on factoring, and we want to try and take out the greatest common factor from each term, which in this case is 8AB. Okay, so I'd like you guys to pause the video and try this one. Okay, so here if we want to first factor 6 times 6, oops, I wasn't supposed to circle that. Okay, 2 times 3, these are both prime. Okay, for 54, I can do 2 times 27, and 3 times 9, and 3 times 3. Okay? I'm just going to cut these up so you can see the difference. Here I have x squared, so I have x, and then also y. Here I have 1x and y squared, so y. Okay, so finding the ones that are in common to both. I'm going to go in the center. I have a 2 and a 2, so 2 goes in the center, it's in common. Here I have 3 and 3. And then I have another 3 and 3 that match. Okay, those are the only numbers. I see an x here and an x here. And then also 1y and 1y. Okay, let's just double check to make sure. Yep, those are the only ones in common. Oops, I forgot to write that this represents 6x squared y, and over here, 54xy squared. Okay, so everything that's in the center is going to be multiplied together to find the greatest common factor. So 2 times 3 is 6, and 6 times 3 is 18. So 18xy is your greatest common factor.